Good morning and welcome to today's session, providing business continuity and disaster recovery to Oracle workloads on a VMware hybrid multi-cloud. My name is Sudhir Balasubramanian. I'm a senior staff solution architect and the global Oracle practice lead for VMware, CIBG. I am supposed to be joined by Kato Grace. He's a senior technical marketing architect. I think he's a bit delayed, so.
No, I'm here.
Good.
Yeah.
Go on.
Yeah. Kato Grace. I work in technical marketing and I cover site recovery manager, vSphere replication, kind of all things disaster recovery and business continuity.
All right, thank you. And without further ado, let's move on to the agenda for today's talk. I'm going to move this out of here. Hang on. All right. So we start with, talking about business critical application, what are the requirements? We'll just gloss over that, right? I'm going to talk a bit about some common concerns concerning, virtualizing business critical Oracle workloads, a bit on Oracle. So primer 101, what does Oracle single instance entail? How does an Oracle rack look like on a VMware vSphere platform without going into much details, into the whole Oracle rack concept, right? And then I'm going to hand it over to Kato and he's going to talk about SRM vSphere replication, VCDR on a high level. I'll hand the ball back over to me and I'll talk about business continuity and disaster recovery for Oracle workloads. And at the end, we'll bring it together and wrap it up with a lot of collaterals. So moving on. So, let's take a look at some of the business critical application requirements, right? So typical business critical application requirements, be that running Oracle databases on VMware vSphere platform, or be that SAP SQL Server, HANA, or Java, or anything in my definition that puts food on the table is deemed business critical application. And these business critical applications, they have certain stringent requirements, right? Like availability, you have performance, you have recoverability, scalability, and security, and so on and so forth. So I'm not going to waste much time on these. You guys have already seen this slide too many times often, so I'm going to move on to the next one. But this is the design methodology when one embarks on the journey to virtualize Oracle workloads on a VMware vSphere platform. And this is a slide I typically use in almost all of my tech talks or VM Live, and this is very critical because there's a point that I want to drive home, that there is no change in the design methodology when one virtualizes Oracle workloads, right, on a VMware vSphere platform as opposed to running the same Oracle workloads on a bare metal, right? Typically, the process starts with gathering requirements. You sell the project to stakeholders. You need to understand the current environment constraints, right? And one needs to measure the database workloads, be that using SAR, be that using the Oracle AWR, the Oracle ADDM, so that you now know what the four quadrants are, the CPU, the memory, the disk, and the network requirements, right, for this particular current workload. And then one needs to inculcate the migration strategy, right? Whether that migration strategy would be moving from, let's say, an x86, right? For example, Exadata over onto VMware, or even from an HPUX, Solaris, AIX platform that we call big endian systems over to x86, right? And once it lands over onto the VMware vSphere platform, right, then we start inculcating design considerations for sizing. We want to make sure that we are compliant with Oracle, right? When it comes to support and licensing, we want to make sure that it has backup and recovery, HA, disaster recovery, monitoring and tuning. So there is no one step in this process that screams out saying that's particular for any physical or a virtual architecture. So in this session, we will be focusing on the backup recovery and the disaster recovery aspect of it. All right. Life of an Oracle DB, right? Typically when you start looking at an Oracle DB, and that, I can even extend that to a SQL Server DB as well, or any database administrator. Typically, right, he or she would have to provide 24/7 production support, right? And most of the database services are with the database design, with the database generation, right? So when you start looking at this flow chart here, or this workflow, day zero typically identify tooling and processes to support database deployment installation. Day one, right? That's where, we need to come up with the database deployment and configuration. But if one were to look at day two, and that's the major part of any Oracle DBA's life or a SQL Server DBA's life, that's essentially keeping the lights on, providing DBA support to developers, right? Be that backup and recovery, be that DB refreshes, be that DB cloning, be that DB patching, any kind of disaster recovery. So it's of utmost importance that these constructs or these verticals, the BCDR, be architected currently so we are able to meet the SLAs, right? We are able to meet the business SLAs, the RTOs and RPOs and so on and so forth. Some common concerns virtualizing Oracle workloads on a VMware vSphere platform, right? That often delay virtualization. the fact that database keeps growing by leaps and bounds. So there's a rapid database growth. And what happens is that's directly proportional to the backup window that needs to be enhanced or that needs to be elongated in order to take the backup for that database that keeps growing. So we have a set backup window. We want to make sure that the backup window, we are able to meet that in order to meet the performance and business SLAs, and we don't go outside the backup window, right? The second challenge we typically see is as database sizes grows, right? It's very difficult to clone. It's very difficult to refresh data from production to QA and other databases because typically, I ask from the development team is, hey, I would like to get a copy of the database because I want to make sure that the new version of software or the new function or the new model that I'm working on, that is able to perform well, right? Or I need to code something, right? So that's a very simple ask from the developers, but unfortunately, it becomes very harder to clone and refresh data as and when the size of the modern database increases. Third, as the size increases, we want to make sure that we are able to ensure rapid recovery from disruption to operations, right? And then the correct choice of DR technology, right? Whether that be the application level, or whether that be VMware vSphere level, or whether that be storage level, that is, inculcated to make sure that the business needs of RTO and RPO are met, right? So these are some of the common concerns, when we embark on this journey to virtualize Oracle workloads on a VMware vSphere platform. So moving on to the Oracle primer before I hand it over to Kato. So, and I'm not going to go very deep into what an Oracle database entails here, right? But from a very, very, very high level perspective, right? Typically, when you look at an Oracle database, right? Oracle database is the physical architecture or the physical structure that's broken down into what's called table spaces, right? So these table spaces are logical entities. They don't exist. They are just logical entities. They are comprised of one or more data files, and those data files are physical entities. So these table spaces are divided into two genres or two buckets. One is administrative, for administrating the database per se. And second, user table spaces where you store your data, you store your indexes, right? You store your lookups and so on and so forth, right? Now, moving from the table spaces, you have a set of other auxiliary components that helps manage these databases. Control files. And the way I describe control files, the control file is essentially, you can compare that to a .vmx because that has the heart and soul of an Oracle database that tracks the physical components of a database, right? The third component is the online redo log file, where essentially anytime you make a change to the data, right, whether that be an insert, whether that be an update, or whether that be a delete statement, the entry or the change or the redo vector needs to go to the online redo log file before the change can actually be made to the block. So that way, when Oracle has to do its crash consistent recovery, right? And we'll look into what crash consistent recovery is in the forthcoming slides, or the undo or the redo. It's not exactly what to roll back or what to roll forward, right? And the fourth component is the archive log files, essentially the set of redo log files that get archived off. And you need that for any kind of media recovery, right? And last but not the least is the database instance. So anytime you hear the word database instance, that's a set of memory structures that manage the database files. So essentially, it's memory where the blocks are read from disk into the database buffers, right, where people make changes onto the buffers before it gets flushed back to the disk, right? So you essentially have the table spaces, the control files, the online redo log files, archive log files, and the database instances, okay? And that's typically what it looks like from a very high level perspective. So when you look at the Oracle single instance database, right, you have what's called the SGA, the system global area. You have what's called the PGA, program global area. We don't have to go very detailed into that. Think of it as the Oracle shared memory where blocks are read into and blocks are written from. You have a set of background processes that works on the Oracle instance here. And that Oracle instance is hosted on a physical server or a virtualized server like ESXi, right? You essentially read and write from a database, and these database and the various components of this database are stored on any kind of storage, whatever the storage may be. It could be NFS, iSCSI, vVol, VMFS, vSAN, and so on and so forth. Moving on. If we have to keep it very simple, right, and extend this, this example over to a n-node Oracle rack, think of it as a 2-node Oracle rack. The only component that I would add here is a private interconnect in the middle. So essentially, the private interconnect is, think of it as a wire, right, wherein the blocks, they get shipped from one Oracle rack instance over to the other, and that technology is what's called cache fusion, right? So before 9i days, when Oracle 8i came out with what's called the Oracle Parallel Server, in order for the second instance to read the block, one would have to write the dirty block from, let's say, rack instance 1 over to disk before you could read that into rack instance 2. Starting 9i, what they did was they said, you know what, we don't want to do it this way. It's called false ping. We don't want to do the false ping. What happened was they came up with this private interconnect where the cache fusion traffic was then shipped from one rack instance to the other. So this is exactly what comprises an Oracle RAC database on a very, very, very high level. Okay. This is the setup of this is an example setup of an Oracle RAC, right? Whatever the underlying architecture may be, right? Whether that's vSphere, whether that's vVols or vSAN, right? The thing I want to drive your attention to is, when you start talking about Oracle RAC virtual machines, there are two genres of VMDKs. One is the non-shared, non-database VMDK, essentially the operating system, and the mount point where you are hosting your Oracle binaries. And then you have a set of shared database VMDKs that you use for the RAC clusterware, right? And that shared database VMDKs, you're able to share it using what's called the multi-writer. And there's a reason why I put this KB article. There's a reason why I'm talking a bit about multi-writer, because when we start talking about business continuity, when we start talking about disaster recovery, there's a curve in the road when you start talking about Oracle RAC clusterware, right? So things like snapshots, when you're able to use snapshot for single instance, you cannot use that for Oracle RAC environment, right? Or essentially for any clustering software that uses multi-writer, any kind of snapshot, any CBT, storage vMotion clones are disallowed, right? And I think I have a slide, the next slide after this, where basically talks about this. But this is one thing I wanted to highlight here, because there's a misconception here in this industry, right? Like anytime we talk about Oracle RAC, well, you know what? I have an Oracle RAC stretched across metro distance, and hence I have disaster recovery. No, you don't have disaster recovery. All you have is high availability. Remember, HA is HA, and DR is DR, and never the twain shall meet. Because when you talk about an Oracle RAC cluster, it's a shared cauldron of data, right? So any kind of corruption that happens propagates to every RAC instance. So in order to have a disaster recovery, one must have a physically segregated database across metro distance, be that using DataGuard, be that using SRM, vSphere replication, VCTR, or storage-based replication. But yes, those two data sets would have to be completely segregated. That way you're able to provide HA across metro distance, if you choose to, along with providing DR across metro distance, so that you have both HA and DR in the same configuration here. Right. I'm going to hand this off to Kato to talk about SRM and vSphere replication and VCTR.
Yeah, and Sudhir, do you want to just advance the slides for me, or do you want me to share? Oh, okay.
I would do.
All right. Okay, cool. Let's do that. Yeah, so we're going to talk a little bit now about Site Recovery Manager, as well as VMware Cloud Disaster Recovery, and kind of a whole bunch of the DR offerings from VMware, and hopefully provide some context for kind of how those will fit into what Sudhir is going to talk about, which is using those tools to recover and be prepared to recover your customers' Oracle workloads. So Site Recovery Manager, to start with, Site Recovery Manager has been around. VMware's had that for more than 12 years now, I believe. And it was one of those, the first use cases that worked really well with VMware for disaster recovery, and Site Recovery Manager was designed to harness that. The basic architecture of SRM is SRM requires a vCenter at each site. It's going to require vSphere hosts at each site, and it requires storage at each site. Now, the storage requirements are going to depend on a few things that I'll talk about next, but the basic thing to keep in mind is that the architecture that SRM requires is the exact same at both sites, because we want each site to be completely independent of the other one. In the event of a disaster at one site, we want the remaining site to be able to handle everything on its own. And that's why we require vCenter, a vCenter at each site. Hosts at each site should make sense, but the vCenter at each site is specifically for that. Then you're also going to have SRM appliances and vSphere application appliances, again, one of each of those at each site. For vSphere application, which we'll be talking about a little bit, vSphere application has no specific storage requirements. Any storage that works with vSphere is supported. vSphere replication can be used for that since it's host-based replication. If we're looking at array-based replication, the basic level of array-based replication, this is where you have similar storage arrays at the two sites, NetApp, IBM, Dell EMC, whoever the storage vendor is, but you have similar arrays and the replication is actually being handled at the array level. For basic array-based replication, SRM uses what we call a storage replication adapter. And that's just a way for SRM to communicate with the storage array. We'll talk a little bit more in detail about that in a couple additional slides. And then we also have the option of virtual volume replication. So when virtual volumes started supporting replication, we added that capability. Took us a little bit, but we added that capability to SRM as well. Next slide, please, Sudhir. So talking a little bit more about those replication options, and then we're gonna drill into that a little bit more as well. So SRM itself isn't a replication solution. SRM is just the orchestrator. And what SRM will do is it will take care of all of the steps that go into the process of getting VMs basically from running at one site to running at another site. So what we're talking about there is it will coordinate from a replication standpoint. So we'll turn off replication. It will promote the recovery site storage to read-write. It will get that those VMs at the recovery site placed into the location that they need to be in order to be recovered. So get them loaded into the correct folder on the right cluster associated with the right resource pool, the right storage policy, connected to the right networks. SRM will take care of all of those things. If required, SRM can customize the IP addresses for the VM, change that as part of that failover process. It can run scripts either on the recovered VMs themselves, or it can run those scripts on the SRM appliance if they need to be run at a different level. So SRM can handle all of those different things as part of the recovery. But SRM itself is not the replication solution. It works with replication solutions to handle that. So vSphere replication is one of those. Array-based replication is another one. VVol replication is kind of a subset of array-based replication. But let's look a little bit more at those different replication types and talk a little bit more about some of the things that they can and can't do. Next slide, please. So the first one that I want to talk about, this is the newest replication option for Site Recovery Manager, and it really is the most flexible, and that is virtual volumes replication. And the idea there is within virtual volumes, we have a concept of a replication group. And what SRM is able to do is it's able to interact with vVols at the replication group level. And a replication group can consist of as few as one VM or, a large number. I actually don't think there's a high-end limit to the number of VMs that can be part of a replication group, but the VMs within a replication group will be kept in a consistent state. So you have that multi-VM consistency capability, and you also have, with virtual volumes, you have the ability to have your replication be really granular. You're able to protect VMs at a very granular level because you don't have to organize them into larger groups. Let's see, I see a couple of questions here, and I'll try and, especially if they're related to the content, I'll try and answer them as we go through. Let's see. So Sudhir's typing an answer to that one. How does vSphere replication handle consistency of a database? So I'll get to that one here in just a second when I talk about vSphere replication. So
I have a slide that talks about it, Kato. So I have a slide that.
Oh, okay, cool.
Yeah, yes.
And then any downside about using SAN replication block level as opposed to vSphere replication. So there are definitely trade-offs between the two. There are benefits and downsides to both. And I'll try to address some of those as I talk about the different replication types. Let's see, and which vSphere release will support vVol replication? I don't know when we introduced vVol replication in vSphere. I want to say
2.0.
Oh, it was, yeah, vVol 2.0. So VASA 2.0, which I think was 6.5.
Yes.
Yeah. But SRM started supporting vVol replication in SRM 8.3. I want to say, yeah, I'm pretty sure it was 8.3. So vVols are, if you're familiar with vVols, vVols are integrated with ArrayBased, vVols are tightly integrated into vSphere. I'm not going to be able to talk specifically about a lot about vVols themselves, just kind of hitting the high-end process of how they interact with SRM. And thank you to Jeff. Jeff posted a link to a blog post where I talk about a number of the differences between array-based replication and vSphere replication. And I'll try to hit some of those as we go through that as well. Let's see. So limitations of vVol replication. Currently, there are some scale limitations. So vVol replication currently only supports up to either, depending on the array vendor, 250 or 500 VMs. That's the scale limit with vVols. And then currently vVol replication is asynchronous replication only. We're currently working on supporting synchronous replication with vVol replication. So that would be another limit. But other than that, I'm not aware of any other limitations of vVol replication. One of the nice things as far as vVols and its interaction to interaction with SRM is that there's no SRA provided, no SRA required when using vVols. Next slide, please, Sudhir. Array-based replication, we already kind of talked about this. This is where you're replicating strictly at the LUN or data store level, or array-based data store level. The challenge with array-based replication, one of them is that regular array-based replication, you're replicating the entire LUN, so you have to tie the protection. You have to potentially reorganize your VMs so that they align with your storage in order to support that. So makes that a little bit more challenging to deal with. But array-based replication, again, is tied to that underlying array function and utilizes the SRA for the communication between that. Go ahead and next slide, please, Sudhir. So vSphere replication is VM-level host-based replication, and this is supported. This is something that's licensed with Essentials Plus licensing and higher, so almost all VMware customers have access to this. And this is the replication engine that's currently used when you're using Site Recovery Manager in the context of cloud-based protection. So for VMware Cloud on AWS, Site Recovery Manager also works with other hyperscalers, Google Cloud VMware Engine, Azure VMware Solution. And currently, vSphere replication is the only replication engine supported for those. vSphere replication, again, per VM level protection, supports RPOs as low as 5 minutes all the way up to 24 hours. And since it's per VM level replication, there's no requirement on the underlying storage. So we can support any storage that vSphere supports is supported with vSphere replication. Yeah, let's go ahead and go to the next slide. The vSphere application and Site Recovery Manager are the basis for the VMware Site Recovery solution for VMware Cloud on AWS. So this is one of the two disaster recovery solutions that are available for VMware Cloud on AWS. And again, vSphere application and SRM are the only thing, the only solutions that are available for that. vSphere application does support a number of different, of additional capabilities that make it unique or have some differentiation between array-based replication. So some of those things are that it supports, it can support network encryption, so traffic encryption. That's on a per VM basis. It can also support traffic compression. So to reduce the amount of bandwidth that's required and reduce the amount of data that needs to be sent across the link, you can enable network compression as part of utilizing vSphere application. It also supports multiple point in time recovery, so an ability to roll back to previous points in time as needed to help with things like database corruption or ransomware, things like that. And it does also support application quiescing, which as is applicable, Sudhir will talk about when he gets more into the specific recoveries that we're looking at. Next slide, please. So the new disaster Site Recovery Manager has been around for a long time. It's specifically designed for on-prem to on-prem. It's also available for on-prem to cloud, like we were talking about. VMware Cloud Disaster Recovery is the new disaster recovery solution from VMware, and it's supported, this is based on the acquisition that we made from Datrium, and it provides, it only supports going from on-prem to VMware Cloud on AWS or between VMware Cloud on AWS instances. And the idea with VMware Cloud DR is that we change the architecture a bit in that we, instead of requiring a SDDC at both sides, requiring a full running SDDC with, vCenter and hosts and storage and all of those things all the time, what we support with VMware Cloud DR is that we replicate to a scale-out cloud file system. Now that scale-out cloud file system is built on top of Amazon Amazon storage, and you're able to utilize the benefits of that cloud storage in that it's dynamic and scalable. There's no, the sizing of it can change as required by the customer's replication requirements, but it's not just replicating straight onto that the Amazon storage. The file system that we build on top of that provides things like a huge number of snapshots that we can take and have the ability to roll back to. Those snapshots are immutable, so they provide a really nice ransomware solution. And it provides the flexibility of, since we don't have to have that SDDC sitting there ready and available all the time, we have the flexibility of and the reduced cost of just being able to replicate to the data to the file system, and only when we need an SDDC, when we want to run a test or when we want to run a failover, we can spin up that SDDC and utilize it just on an as-needed basis. So you end up with a lower cost solution that provides still provides a good RTO and RPO, but slightly higher than what you would get with Site Recovery Manager or VMware Site Recovery. You can also, with VMware Cloud DR, you can also utilize a pilot-light SDDC, so to reduce the amount of time that it will take to run a recovery You could have a small SDDC, not big enough to support the entirety of the workloads that would be failed over to it, but have that SDDC there and available so that in the event that you wanted to do a test or a failover, it's easier to scale up that environment. But that's not a requirement. You have the nice thing with VMware Cloud DR is you have that option for how you handle that recovery. And yeah, go ahead and next slide, Sudhir. So just like with Site Recovery Manager, the failover process with VMware Cloud DR is entirely orchestrated. So there's no manual steps that are required by the operator or whoever's running the DR plan. All of the steps that would go into the recovery process are going to be laid out beforehand. And then when you want to fail over to the recovery site, all you have to do is kick off that recovery plan, and VMware Cloud DR will take care of the whole process. And just to keep in mind, that whole process can include everything from creating an SDDC and spinning up that SDDC to or expanding an existing pilot light SDDC. But that whole process can be enabled as part of that failover. But the powering on of all of the VMs in whatever order that they need to be powered on in, customizing IP addresses, running scripts, all of those capabilities are available with VMware Cloud DR as well. So that is the end of my portion, and I'll pass it back over to Sudhir, and he'll talk about how we use those tools to recover Oracle.
Thanks, Kato. Right, moving on to the next one. So the first section we'll talk about is providing business continuity to Oracle workloads, and then we'll talk about the DR aspect of it in the second section. But looking at this slide, essentially providing BC and DR for Oracle workloads on VMware level, essentially you can divide that into three different levels, right? Providing both BC DR to the Oracle workloads at an application level. Second, providing the same BCDR for Oracle workloads at a VMware vSphere level. And third, at a storage level, using pretty much all of the tools that we have spoken about in the call here today, right? Whether that be VMware Snapshot, VMware Clones, Kato spoke about SRM, vSphere replication, right? He spoke about ArrayBased replication, he spoke about vVol replication, and VCDR. So this section we talk about providing BC and DR at these three levels for both single instance and Oracle rack, on premises and to the cloud. Right? So even before we go there, I just want to call your attention out to this one particular slide. So essentially, there's a curve in the road here when we start talking about Oracle rack, and the reason is, the way that we set up an Oracle rack, as I've showed in the previous slides, is by using what's called multi-writer flag. And when you use the multi-writer flag, you're now able to share VM DKs among several virtual machines that comprises a rack cluster. So there are pros and cons to this approach. Pros to the approach, you're able to set up an Oracle rack cluster. The cons to that, snapshots are disallowed, cloning is disallowed, storage vMotion is disallowed, CBT is disallowed as of this point of time. So the two KB articles are put in the bottom of the slide here, the 1034.165 and 212.1181. Essentially, those are talking about restrictions when one uses multi-writer flag on either the non-vSAN or on the vSAN layer. So keeping this in mind, these are the current challenges we face. Keeping these in mind, let's start talking about the Oracle, the backup, the business continuity aspect of this discussion here today. So from a very high level, right, when we start talking about Oracle backups, and we don't have much time to go into deep, right? Typically, when you talk about user managed backups, that could be the cold backup of the offline, that essentially shut the database down, you back the database up, you start the DB up, right? That's been something that customers have been doing, DBAs have been doing for many, many, many years, right? And at some point of time, people started thinking, well, there's a breach in SLA, can we do something that's hot? Or can we do something that's online, right? And then Oracle came up with what's called the hot or the online backup. Essentially, you put the database in a begin backup mode, you back up the database, and you take the database out of the end backup mode. And there's a lot of mechanism that goes in play here, essentially. But by doing this, you don't have to shut the database down. And last but not the least, at some point of time, the storage vendors, they came out and they said, you know what, we don't want to go the cold backup route, or we don't want to go the hot backup route. Can I take just a snapshot of a running database, and would you, Oracle, then promise to bless it and say, yes, it's an acceptable way of backup? And then Oracle did the research and they came back and said, yes, we come up with what's called a crash consistent backup, crash consistent database backup. So essentially, anytime you take a clone of a running database, right? Be the clone on a VMware vSphere level or even a storage-based clone. We'll see that in the forthcoming slides. When you bring it up, Oracle then does his magic. Oracle does what's called the instance recovery or the crash recovery, and brings the database up and make sure that the data is consistent at that point of time the snapshot or the picture was taken. Right. Again, this is more to talk about the Oracle backup tools in detail. We won't have time to go into it. But if you look at the middle of the slide here, this is what we recommend for customers. So when customers run Oracle workloads on VMware vSphere platform, if you guys have the ability and the flexibility to take RMAN backup, recovery manager backup, that's a route we typically recommend. That's what Oracle recommends, and that's VMware recommendation as well. The pros to that is there is no database in the begin backup mode and end backup mode. There are no cons to it. RMAN knows, or RMAN has the internal know-how how to make sure that the blocks are then transformed in a consistent manner. So there is no consistency check or extra consistency check that needs to be performed here. So that's a recommendation as well. But moving on to the various business continuity, solutions that we have. So from an application level, whether you're running it on premises, whether running it on the cloud, whether that's a single instance database or an Oracle RAC database, any of the Oracle-based mechanism works, whether that's a cold backup, whether that's a hot backup, whether that's crash consistent, whether you're using Oracle RMAN, whether you're using data pump, right, or even external tables, or even if you're dumping data onto a CSV or a flat file, they work seamlessly, whether it's on premises or on VMware Cloud. Now, when we go one level down onto the VMware vSphere level and we start, taking advantage of technologies like Snapshot and clones, it works both on premises and it works on VMware Cloud as well. Only difference is with VMware Cloud, there is no VMKFS tool capability. Unfortunately, neither of these two technology, right, you can use it for Oracle RAC. I've already spoken about this, the issue with the multi-writer flag. So this is only for a single instance. So for example, right, if you have a virtual machine, you can shut the database down, take a VMware snapshot, that's a cold backup. You can either have the database running and put it on a hot backup mode without coercing, right, the pre-freeze and the post-thaw commands, and take a VMware snapshot as well, or simply just take a VMware snapshot. And there was a question that was posed up by Charlene earlier, right, that's saying, are these snapshots or even VMware vSphere replication, are they consistent? And the answer is yes. The VMware vSphere, the VMware snapshots, they are point-in-time snapshots. And the write order fidelity, this is very important for any kind of database. The write order fidelity is guaranteed for all VMDKs for that virtual machine, right? Similarly, with VMware clones, you could either take it from the VMware snapshot or you can clone directly from a virtual machine. Remember, when you clone it directly from virtual machine, based on if the VM is up and running, it's a crash consistent clone. If the VM is down, if the source virtual machine is down, then yes, it's a cold clone, right? And then if you go one level down onto the storage level, right, you're now able to take a storage-based snapshot of a LUN that's backing a VMFS data store. There are pros and cons to every approach here. The pros to the approach is that's the fastest you can do, right? The cons to that, it lacks VM-level granularity. So it's the granularity is that of an entire LUN. And if you have to bring it up, then you would have to resignature the LUN, bring it up on the ESXi cluster, and then you can restore from the target LUN over to the source LUN, right? Or if you were to use the vVol-based snapshots, the best part about vVol is you get what's called the VM-level granularity, or even the VMDK level granularity. So either of the three ways of backup, the cold, the hot, or the crash consistent, you're able to do that with vVol-based snapshot as well. Again, the issue is it's not you're not able to use that for RAC, even if it's vVol-based snapshot. It's the same restriction above. It's the multi-write which is the issue up here, right? So these are the different business continuity solutions that we can have when you start looking at these three levels, right? The application level, the VMware vSphere level, whether you're using snapshot or clones, and the storage-based level, whether you're using a LUN-based snapshot or even a vVol-based snapshot. Now, let's take an example here. Hopefully, we do have time to cover a couple of example scenarios. But looking at a crash consistent virtual machine snapshot of a single instance database, you would go about the same way as you take a snapshot for any virtual machine. And once you do that, right, and if at some point of time, if there is a need to revert back to this to a point in time snapshot, our recommendation is shut the virtual machine down, follow the above steps, essentially, which means revert back to the same snapshot. And when you come back, it all depends on what the virtual machine was doing at that point of time. So let's say if the VM was cold when you took a snapshot, there is no cache consistency that you would have to ensure. If the VM was hot and if you revert it, when you start the Oracle database up, Oracle database typically does two things, right? It does what's called a roll forward, right? So it'll make sure that everything is rolled forward at that point of time where something happened, right? Whether the plug was pulled out or the database was shut down or the power went off. And then it does what's called rolling back. It roll back the uncommitted transaction. So the rolling forward and the rolling back would then ensure, right, that the database is brought up consistently till the point of time. So that internal mechanism is built into an Oracle database. So you would not have to do anything special unless there is any kind of media recovery that is required, which is a different scenario altogether. Okay. And I just gave an excerpt from an alert log file. So every Oracle database has what's called an alert log file, just like a virtual machine has a VMware or log file. Every Oracle database is an alert log file. So anything that happens in the Oracle database get logs in there. So when we did the restore from that snapshot, right, or from that clone, right, and then when we brought the Oracle database up, if you look at the bottom of the slide there, it says completed crash recovery. So it does that crash recovery mechanism, the rolling forward and the rolling back. So yes, any snapshot at point of time, clones, point of time, the right order fidelity is guaranteed, which is very, very, very critical for any database, be that Oracle or be that SQL. Right? So changing gears and talking about storage-based snapshots, right? So again, I think I already spoke about it in the previous slides, but if we were to have, let's say, a VMFS data store, we take a storage-based snapshot of the LUN up here and we create a clone of that LUN. We attach the LUN to ESXi, right? And of course, resignature it and we rescan it, right? And then what we do is we can then register the copy of the original virtual machine or the source VM as a copy where we bring the virtual machine up, the new VM up, and then once it comes up, Oracle does its magic. Oracle does the crash recovery, which is normal, which is expected. And then once you have the target virtual machine up, if you have to restore anything from the target virtual machine, if you have to copy any data out to the source virtual machine to fix the database, so be it, right? But this is another way that we could provide business continuity to Oracle workloads at an array base or at a storage base. And again, the VMLevel-based snapshots, I don't think we'll have time to go into it, but I have given the link is provided at the bottom of the slide, and that basically goes into all of the details for VMLevel-based backup and restore. But moving on to the disaster recovery aspect of the discussion here today, right? And again, this has been provided just for reference. We don't have to go into it. But again, when you start looking from an Oracle database standpoint, right, you have many ways you could do it. You have the physical standby, right, the physical data guard. You have the logical data guard. You have the snapshot standby. And you have something what's called an active data guard. The difference on a very high level between an active data guard and let's say the physical data guard or the logical, I would say more of a physical data guard is the active data guard is open for operation, right? It's open for shop. So people can use the database as a read-only while the redo vectors or while the changes have been applied from the production database over to the data guard. So that aspect of activeness is missing when you talk about physical data guard. But these are the different solutions that are available when you start looking at disaster recovery from an application perspective. Right? Now, let's see how we can provide disaster recovery for Oracle workloads, right? When we start looking at those same three different levels, right? The application level, the VMware vSphere level, and storage level. And as I mentioned before, right, data guard, whether that's physical, logical, snapshot, active, golden gate, DB visit, any third-party product, right, that works the same exactly, whether you're on premises, whether you're in the cloud, both for single instance and for Oracle RAC, right? Now, let's come one level down. When we talk about VMware vSphere, and Carter has gone deep into the VMware Recovery Manager, the SRM with vSphere replication, right? Thing to keep in mind, I think there was a question up there, right? Right order fidelity is guaranteed with VMware vSphere replication on the VMDKs that comprise the virtual machine. So when you use SRM vSphere replication to protect any virtual machine, right order fidelity is guaranteed. So when that virtual machine is brought up as part of any recovery plan, Oracle does its magic. Oracle does the crash consistent recovery or the instance recovery and make sure that the database is consistent. Now, there's a bit of a curveball up here. A vSphere replication that cannot replicate virtual machines that share VMDKs, right? So if you have any configuration that has multi-writer flag, that is disallowed as of this point of time. It is not supported. So for Oracle RAC, we cannot use SRM with vSphere replication. But yes, absolutely, you could do that for single instance. Again, when you go to the cloud, and Kato spoke about it, you have the same flavor, right? The VMware SRM with vSphere replication, we just call that VMware Site Recovery, VSR, but the same thing applies there as well, right? We talk about the other offering, the VCDR. That's not on premises. That's in the cloud. VCDR uses Snapshot, and as we have seen as in the earlier slides, VMware snapshots, point-in-time snapshots, write order fidelity is guaranteed for all the VMTK across the virtual machine. So yes, it will be consistent, right? The data would be consistent. Again, it's only for single instance. It's not for Oracle RAC. Why? Multi-writer flag, snapshots are disallowed, CBTs are disallowed, storage vMotion disallowed, cloning is disallowed. So that's the limitation, current limitation that we have with multi-writer flag. So that's something that we have to work around, right? So, and the third level, when you start talking about disaster recovery at the storage level, right? You're able to do that using SRM with ArrayBased Replication. In this case, you can do that for both single instance and Oracle RAC, right? It goes back to the same business continuity discussion as well. It lacks VM-level granularity. The granularity is at learn level, so it's pretty much everything. It's all or none, right? It's pretty much all. And the DB consistency can be anything. It can either be cold or it can be cache consistent, right? Again, when we start talking about SRM with VMware-based replication, you get the virtual machine level granularity. That's typically what an Oracle DBA would like to have, an application, a virtual machine level granularity, so that any kind of restore that happens, right, happens very fast, very blazingly fast. Again, you can use that for both single instance and also for Oracle RAC. I'm going to move on to the next one. We take an example, right, using SRM vSphere replication and run the recovery plan for DR. So again, the steps are exactly as shown in the illustration here. This was a DR simulation. This is not an actual DR. So yes, Site A was available. Once you have the recovery plan set up in place, and once you're able to run through the recovery plan, right, what we were able to see that the protected virtual machines on Site A, so we had two sites, we had Site A, we had Site B. The protected virtual machines on Site A, they were powered off. The Site B, the recovery virtual machines are powered on. And when it comes on, as I mentioned before of many times, Oracle does its magic. Oracle does the crash recovery. That's performed when the database comes up. We had a look at the alert log file. They had no errors. It basically said completed crash recovery, database consistent, database is up and running. And again, just want to repeat up here, write order fidelity is guaranteed with vSphere replication on the disk or VMDKs that comprise a virtual machine. And that used to be a major concern. When we started this project, right, as part of talking to customers across all 4 geos, the question that I used to get is when we use snapshots, or if you were to use clones, or more so if you were to use SRM with vSphere replication for Oracle databases, if we replicate those VMDKs that comprise the Oracle database from point A to point B, are they crash consistent? Is the data guaranteed? Do we have any kind of write order fidelity? So all of the tests we did, right, we basically proved that yes, write order fidelity is guaranteed and the database comes up consistently, and there is no corruption and there is no loss of data. So that's something I definitely want to underline here today. Moving on to the Oracle DR using to cloud using VCDR. It's again the same set of steps. The failover completes, and once the failover completes, you have to go in and type in commit. And once you type in commit, then the plan transitions over to the failover committed state. The virtual machines are migrated using storage vMotion. The crash consistency or the crash recovery is performed by Oracle, does the same magic. Alert log file for the database shows no error. So any point of time, right, any operation happens, the first order of business is to check the Oracle alert log file. And looking at the alert log file, it'll tell you if that operation went south or the operation was successful. So that is the first check that one needs to do, right? Again, using storage-based replication, DR on premises, right? Steps to run the recovery plan is shown as here. When we ran the recovery plan, it was successful. Again, as I mentioned before, the Site A was still available because it's a simulated DR. So what happens is we use pure storage. And then when we use pure storage, the pod was promoted on Site A. The pod was promoted on Site B. We had a look at the alert log file as expected and as normal. No issues up there. Oracle does its crash recovery when the database comes up, right? Again, key thing to underline up here, storage-based snapshot, cache is crash consistent, and the right ordering is preserved for each file within a snapshot. All right, So bringing it together before we open it up for any further questions, right? Essentially, this slide talks about it all, right? So when you start looking at providing BCDR for Oracle workloads on a VMware vSphere platform, right? It'll be good if we were to separate that into 3 different levels, right? Application level, VMware vSphere level, and storage-based level, and then start looking at every level and start looking at every tools that are provided at the level, right? What are the different tools that are provided at the app level? The different tools that VMware vSphere provides you, whether that be Snapshot clones, whether that be SRM, vSphere replication, array-based replication, or whether that's VMLevel-based replication. If you have to go to the cloud, you have VSR, you have VCDR, right? And then once we look at 3 different levels, then the second outlook or the second perspective is, what is it that the customer wants to do, right? What is his use case, right? What are the pros and cons for each and every layer and each and every tool that we use in layer? And that way, if we were to come up with this matrix, then we are able to pick the best BCDR solution that is good for that customer environment, right? And every customer environment is, of course, one different, right? And the link at the bottom of the slide is the 300-page Bible that essentially goes into all of these use cases across all of the 3 levels using all of the tools that we've spoken about in this session here today. It talks about providing BCDR on premises, talks about providing BCDR in the cloud. It has screenshots as to set up BCDR for Oracle workloads, right? It has a lot of detail in that, so do definitely give it a look. But then wrapping it up, some key takeaways, right? And that's the only one key takeaway that I have for you guys here, right? Any Oracle white paper, any other Oracle white paper, be that the best practices, right? Be that Oracle on vVols, Oracle RAC, Oracle BCDR, Oracle with persistent memory, and we're working on PBRDMA as well. Anything and everything, including Oracle licensing, which I know you guys love that topic a lot, right? Those collaterals can be found on the one-stop shop, so please do bookmark it. But I think we are at the end of the slide, or end of the session here today. So I'm going to open this up for any questions.